Hello class, today we're gonna cover the Weka software, which is a machine learning and a data mining software. It's used by large community of researcher and developer. What we're gonna download today is the latest version of the development version. So if you go to download, and based on the operating system that you have, if you have a Windows and based on which type, if you have the 64-bit, 32-bit, you have to pick the right version. So as I said, I would like you to develop any one of those under the developer version, which is the version 3.7.2, will show in your platform as a 3.7, but this is the latest version. After you do the download, you will have Weka interface, which is look like this. So you can go, for example, if you are on Windows, go under C program files, you will find a folder Weka, and in Weka you just click on weka.jar and the application, the GUI interface will open automatically. If you want to run it from the command line of Windows, you can go to from the start and you can write CMD and then you write Java jar then weka.jar, so you can run the application and you have a command line as part of the materials in Unit 3. Now what we're gonna cover in Weka is not all, because some of them are very simple, and as you notice today I am using Mac just to have a variety of different operating systems to show you that Weka works in many different platforms. If you are using the Open Linux O2s, also it runs on it. If you are using Windows or Mac, this application runs on all of them. If you are using operating system that doesn't have command line and you would like to use the command line of Java, you simply click on the command line, and from here you will write based on the first you put the path where you have Weka, and you will just run Java and then jar and then Weka. Of course you have to be in the path of where is Weka allocated, and you run it, just you click enter and will be running the application the same time. Or this is more specifically if you don't have enough memory. Also, if any one of you has a problem with running Weka with a memory, just shoot me an email. I would rather the email, because this is how I am alert more than going to discussion board. I go to discussion board just over the weekend to see what kind of posts you have been posting over there. Now the second one, which is not gonna use, the experimenter. Actually this interface is very simple interface for simple data, so we're not gonna use this one. The two applications that we're gonna use is the Explorer and the Knowledge Flow. I'm gonna talk briefly now about both those. In the program you can see the log windows. This is like whatever you are working with Weka and errors you get, or applications or Java maybe Java files that you are running. For example, here we are retrieving the driver for the database related to the SQL database, so you can know what kind of command we have been running. We run the command line, that's why you can see this one here. So technically it keeps logs of whatever you are doing, and if you go to your folder of Weka, there is a specific folder, it's log change. You can see the changes every day of what you did using the application. The second one, the memory usage, if you click on this one you see the garbage collection. As you know, Java use a garbage collection to clear the cache and to not to shut down. So far we are good enough in using Weka. Visualization, we're gonna see the visualization from two different point of view. From here I can show you a little bit of visualization. Now to be able to visualize, technically you have to find Weka and to visualize data. You will find Weka, in your case on Windows, under the program files, and you will find a folder. The name of the folder is data, and this is all the samples that bundled with the Weka package, and you can use those just to train yourself of data mining algorithms. For example, Iris is one of the most popular data set, one of the beginner data set related to the flowers, and we can use this one just briefly now to show you the distribution of the data. So as you can see, we have 3 different color of type of data. That means we have 3 sets, and they are distributed, you see, as if the blue is completely separate. So this is like a very separate, unique cluster. Like if I draw a circle around this one, this data, it's really unique, whereas the green and red are interacted with each other. So we'll see what kind of data is really this one. Another type is the ROC function, is very popular. This function is if you are technically, if you are doing any research, most of the time you will see in the research that most of the people, they show their ROC, or they name it also the ROC function, that shows the goodness of their data and how much their algorithm improved the result of maybe clustering or maybe classification. We're gonna see those topics. Just I'm giving you a brief overall view of the application, how it looks, where you go to find those information. As you can see with ROC, we were able to separate the data into 3 type or 3 clusters: the blue alone, the red alone, and the green alone. This is the type of visualization that we can be using. Another type also I'm not going to cover. The type of files that Weka accept is ARFF type, and this type is a little bit unique. So let me open the data, and again I have to go to the folder of Weka, and not this one. Okay, Weka and data, go to the Iris. We are stuck to the Iris now. So this is our data. So you are familiar with databases. This data has 4 attributes. The first one is this attribute is the sepal length related to an attribute in the flower. The second one is a sepal width. The third one is a petal length, and the fourth attribute is a petal width. And then we have the class. The class shows, okay, if I have this combination of attributes, like if the length of the sepal is 5.1 and the width is 3.5 and the petal length is 1.4 and the petal width is 0.2. So I am in type of a flower. The name of this flower is Setosa. Okay, so we have a data set of 150 samples, which is not big data set. Technically I cannot apply data mining. Usually you will say data mining, you should have at least 10,000 samples to apply it. So we are not really doing data mining, but we are learning the algorithm, and after maybe a couple of weeks we can apply our applications on a bigger data set. So this is the first type of the data. So we have the first 50 samples that have this kind of attributes. Like for example, the petal width is never been bigger than, for example, here I cannot see number 2. So if it's less than 2, so they fit into this category, for example. The second type, the second collection of data from 51 and continue until, you can see here, until 100. This data set has different kind of combination of attributes that fall into the category of type of a flower, versicolor they name it. So this is the class, second class. And the third one, which start from 101 and by 150, but this is the third type of the type of flower. So also it has some specific. You can also edit those files. The note here that all the type of file that Weka accept is ARF files, but the good thing that and as we said, we're gonna use the Explorer, that you can really import data from Excel into Weka. And when you import data, like open a file, From here you can see it accepts CSV, which is typically if you have any data set in Excel or in MATLAB, for example, it accepts MATLAB also. If you have data in Excel and save them as CSV extension, you can open them in Weka, and then you can save them in Weka in the format that Weka likes, ARFF. So that's the trick that you use. We can go and talk about the attributes of what really RF it stands for, or why we have this attribute. Maybe if some of you already opened the reading material 3 and saw the attribute at the beginning of any data set, we don't have to do this manually. When you import the data, automatically Weka will add this information for you. Now, the interface of Weka, first we have the pre-processing. The pre-processing, it's just to tell you a very typical concept in data mining, garbage in, garbage out. So if you have a huge data and you spend years and years collecting this data, and then you didn't clear this data or purify this data, and you just run the applications like blind user, actually what you end up with garbage out. So technically you have to do some pre-processing, and this is what usually they say, it's 90% of your time you are pre-processing the data, then you apply the algorithms such as classifying this data or clustering or association rules, and we're gonna see those. So let's go ahead and open our iris data. So again, we're gonna go to Weka, and from Weka we can go to the data, and we're gonna open the iris. So here the same attributes that we saw before, those 4 attributes are available here for you. You can actually ignore some, or if you want to see all of them. Also we have the class, it's already classified for us, so this data is already purified, and even there is a class created for us. It tell us which attributes of a samples fall into which class. However, we can change those, we can play with those if we are not satisfied with the data that with the type of classes that this data being provided to us. Now the second type, you can also, if you know there is a data on the web, you can just put the URL and automatically Weka will accept this data and you can work on it, and then you can save it, of course, so to run on it locally. If you want to run some, you can import some data based on the query that you have this data in database. Also, you can do this. We are not gonna touch on that one. If any one of you interested in this one, we can cover this subject. Generate. Now, if we have Weka in one format to other format, also we can generate some different format. Also, I never used this option before. Editing the data. If you are not satisfied, you feel like some of this data is wrong, you can go ahead, and especially if you are the collector of this data and you notice some outlier is not really right, it shouldn't be in this category. So technically you can just double click and you can change this one to what you want, just add the number you want and the data. I'm not going to save the data, I'm not going to ruin the data the way it used to be, but this is a way that you can edit. Now all the algorithms that we're going to use from now on are available under those tabs. You can see them a little bit different on Windows, but the same concept. Visualization, you can see the visualization of those data. You can just maximize to see a better look of this data. And also, what else? You can maximize a point, so just to be able to visualize the data in a better way. Also, we're going to talk about, so today this session only overview of the applications. We are not using it, we are just giving you an overview of Weka application. Now the filter, as I said before, doing any type of algorithm, applying any data mining algorithm or machine learning algorithm. You may ask me what the difference between machine learning and data mining. Data mining actually is it's a new terminology for many different area of research. So the statisticians, they claim that data mining came from statistics. Machine learning community says no, data mining came from the machine learning. The neural network community would say data mining was born from neural network community. And so far, you will see a lot of debate over this concept. But Weka, because the lab that created Weka is a machine learning lab, so it falls into the category, it says machine learning and data mining application. So we're not going to discuss this. This is a big debate between the researcher, and we'll stay away from that one. However, if we open a data set the way I did, I just went to the open file and I searched for iris.arf. If you want to apply a filter, and here it's like the concept of any filter. If you use Photoshop, you are using filter sometimes to take off noise, and the same concept here. We are using the filter to take off noises in the data or outliers in the data, and make the data more pure. Two type of filters we have. Supervised, that means there are rules and you are applying those rules on your data. A set of rules that already been defined and you're applying it. The unsupervised, it's a different type of filters that you keep applying multiple, you will see it's a huge amount of filters we have here. You keep applying those rules one after the other until the end you are satisfied enough, and you will say, okay, this is what I want to use. So it will be a combination of multiplied rules, and is not set from the beginning. You are the one who is tailoring those filters, and we're gonna see how those filters will affect our data and which one you apply it on different data. So each data, you will see with time, you will learn that some filters work better on some data, some other filters work better on other data. So this is the filter. And after here, for example, let me choose one and show you what kind of changes that this might cause for the data. So this is, you pick the filter and then you just click apply. So see, I have now a little bit different visualization look for my data. So we'll talk what the meaning of this filter with time, but this is the way the filter works. I am gonna close this one, and I'm gonna go to the interface. The second type, which is a knowledge flow. Knowledge flow, you can imagine it as if parallel execution of the experimental that we did, or the explorer that we did. So the same data, you can apply more than one algorithm at the same time. So you have one input, one data. You might have more, but most of the time you have one data, and then you apply multiple algorithms parallel, and then you look at the output, and you will decide which one fitting them best for you. We're gonna play also with that one, and we'll see how effective it is. So far, this is an overview for using Weka. If you are not able to use Weka, send me an email and let me know. I'm having problems. Sometimes the memory, there is a specific code. You can run it from the command line. You can increase the memory of your PC to make it work better with Weka. So good luck, and I hope you start using Weka. Okay, and yes, Andre, I am usually doing the video over the weekend, so you have a credit for finding my pattern of behavior. Okay, good luck.